Hello, can you hear me now?
Yeah,
How
how
are
you
you
doing?
guys? How are you guys doing?
I'm doing good.
Um, Today our focus will be to complete what we started last week. Just give me 1 minute. Let me close this. Okay. Okay, I have this most, I have this. Okay, good. Yeah, we last week we stopped, we finished, I introduced you to normal distribution and we did some calculations there. And then this is where we stopped, which is finding data values, giving specific probabilities. If we finish this tonight, then I will introduce you to confidence intervals. And then we go from there. Okay. So before I proceed, I want to show you something in your classroom for this week. For this week, actually, we are supposed to start the confidence interval today, but because we didn't finish this, it's my announcement. You can see that we're supposed to start confidence interval today. So since we have to finish what we have last week, I will have to move this test and homework to be due on the upper week so that you have time to review. So instead of 26th, I will make it due on May 3. That should be better. So there's no classwork due today, so I'm sure you should be good. Want you to take the time to review. And I also have this for you. I have the review materials for confidence intervals here for you for the test too. Right, you can download it and use it to practice before you take the test. Okay? And then homework. So I'm gonna move this to not this Sunday, but the Sunday after this one. So let's begin. So when we need to find the given data values, or when we want to find X, which represents uh, specific data values, or when we're given probability, we use this formula here on the screen, which is X equals Z times delta, as is the standard deviation plus the mean. So where S is the data value you're looking for, and the standard deviation is the delta represent the standard deviation, and mean represent the mean. So for that, you can either use the formula method. Before you can use this formula, you need to find Z, first of all, the value of Z from either from the table of normal distribution, or for this class, we are using Excel to find it. We can do that. So let's try an example. Now for Excel formulas we'll be using for this, if the is on the left there, you use num.s.inverse times then put the area in parentheses. Area here means the given probability. And for the right side, you use this one, num.inverse dot num.s.inverse, sorry, dot x dot inverse. Okay? Then 1 minus area if it's on the right tail. Now for two tails, you use this one here. Num.s.inverse parentheses 1 minus area over 2. So let us try this for some questions we have given here. What does this space for that? It said to qualify for a police academy, candidate must score in the top 10% on a general ability test. The test has a mean of 200 and there is standard deviation of 20. Find the lowest possible score to qualify. Assume that the test scores are normally distributed. So the formula for finding the lowest score to qualify is this: x, as I explained a little bit ago, equals z times delta plus mean. But before you can use this formula, you need to find x. For that, you're going to use this Excel formula here, which is num.s.inverse. How do I know that? Because when we draw this, look at this, we are told that um, the mean is equal to 200. Yeah, and that the standard deviation is equal to 20. Okay, then the area I was given for you says the top 10%. Top 10%. Okay. Now, if you draw this in a chart, it's gonna look like this. I'm going to put, of course, 0 here. Then you can put the right here. I'm gonna put this line for the on top of this. Then I can draw the bear curve. So that the area will be, see the center line, and that is the center line. So this is the top 10%, it says. Okay, so I'm gonna share this place. Okay, which represent the top 10%. Okay, so the top 10% is right here. Top 10%. This is it right here. This is like the cutoff. It starts from here, right here. That's the top 10%. Everything below it is 90%. Yeah, 90%. So, and we need the Z for here, before we can be able to answer the question. Okay. So, okay, I got this. Let me put somebody else's name here. Okay, right here. Okay. Now, so you can see that we need the Z, we need the delta, which is standard deviation, is given as 20. The Z, we don't know. And mu is given as 200. So when you look at it, that means you're looking for this is the space we're really looking for, this cutoff. Where it says, find the lowest possible score to qualify. Once we get our Z from the table or using Excel, we can just plug it into this formula and we get our answer. So I'm going to write this down so we can put it in Excel and so we can get our Z. Oh, stop it. Okay. I got mean is 200. Another difference is 20. So the area that was given to us, top 10% right here, is 10%. Okay. So we're going to use this formula. The formula is equals num dot s dot inverse 1 minus the area. Okay. 1 minus the area because we're looking for only this portion. The whole of this is 1. So let's go and get it from Excel. We have right here the area given is 10%, which is in decimal is 0.1. So that Z equals hope you're seeing the screen. Make sure you're seeing the screen. Okay, good. Z equals num dot S dot inverse, put opening parenthesis, click on this. Actually, it's 1 minus area. So 1 minus that area right here, close parenthesis. And then once you press the enter key, it will give you the Z, which is 1.28. One after you round it. Usually we use 2 decimal places for Z, 1.28. Okay? So we can go here and put 1.28. That our Z. Z equals 1.28 from Excel. Okay. So with that, we are ready to calculate the lowest possible score to qualify. So that the lowest possible score to qualify, I'll call it lowest score X equals Z, okay, times standard deviation, which is the delta, plus the mean. Which means equals, mean is 200, sorry, Z is 1.28. Okay, make it not italics, times 20 plus the mean of 200. Okay, so let me write this down. 1.28 times 20 plus 200. Now you can go and put this in a calculator if you like. Okay. So we have we got 1.28 times 20, which is standard deviation, plus 200, which is the mean. It gives me 225. 225.6. As you can see from the screen, 225.6. 225.6. Any question on this? Any question, guys? Yeah. All right. Since there's no question, I can proceed to the next one, which is the next question in the list. Okay. Which is this one. It says, for a medical study, a researcher wishes to select people in the middle 60% of the population based on the blood pressure. If the mean systolic blood pressure is 120 and the standard deviation is 8, find the upper and lower readings that will qualify people to participate in the study. So here, I'm going to put this in below is, okay? Okay, we are told that the mean is 20, so is 120, and the standard deviation is 8. But they need the middle, you have to fall within the middle 60% of the population to qualify for this to participate in this study. So we need Z. We need Z. But if I will calculate, I want to show you something. Let's say I'm going to put C here. Z equal, we don't know what it is. So I'm going to just make it 18. Okay. So before we do, I want to show you something. Um, Let me move this to the next line so that we can have enough room for this. Okay. To qualify for this test, you have to fall in the middle 60% of the population based on your blood pressure. So that I'm going to show you how this chart will look like. They're going to be Z, 2Z, middle. That means they're going to be two Z's, lower and upper, because of that, you have to be in the middle. So they're going to be Z1, 0, and Z2. Okay. So now I'm going to put the chart so you can see how the chart will looks like. Oh, excuse me, my mistake. All right, put this one. Okay, I'm going to put this chart right here. Okay. Now put this here. Okay. All right. So this is the center line, which is the mean. Then on both sides, I have Z1 and Z2. The middle 60%. 60%. Okay. You have the Z1 and you have your Z2. Okay. Now I'm going to share this so you can see how the middle 60% where I'm referring to. This is the middle 60%. And I wrote it there so you can see it. Okay. All right. Okay. All right. So right here. So this is middle 60%. So that means we need to get the X1 and X2. The lower reading is S1, upper reading is X2. So to find Z, then it's going to be Z1. I'll bring it down to this place. Z1 and then Z2. So I'm going to make it, to look like, format this a little bit. Z2 and Z1, So to find both the Z2, once you get Z1, you get Z2 because by symmetry, it's the same on both sides. I said that Z1 will be negative and Z2 will be positive. Okay? And the formula we use in Excel, I have it right here to get the Z is, make sure I've seen this. Yep. It's right here. Let me highlight it for you. Num.s.txt. Here, the area given, I'll call this area is 60%, which is the probability. Equals 60%, which is 0.6 in decimal. Okay? So you can now go and put this in Excel. So you're going to be equals num dot s dot inverse in parentheses 1 minus, okay, 1 minus area, but 2. That will give you Z. The area is 60%, as you can see, which is 0.6. So you can just go to Excel and put this in. So in this case, the area is equals 60%, which is 0.6. So that Z1 Okay. Um, I put equals um num.s dot inverse. Okay. Opening parenthesis. 1 minus in parenthesis. 1 minus area. The area is 0.6. Okay. Over 2. Then close the parenthesis twice. So they have two parentheses, have two opening parentheses and two closing parentheses. Press the enter key, give negative for Z1. I think there's something we missed here. I didn't put divided by 2. So let me do it again. Z1 or 2. Okay, make sure. Oh, a mistake. I put the 2 at the wrong place. A divided by 2. 2. Okay. So I put the 1 minus 1 minus the area in parentheses, then divide by 2. We'll divide by 2, it may 0.84. But you have to be negative because it's on the left side. Okay. So I'll make it two decimal places. So for Z1 is on the left side, so this is gonna be negative. So negative 0.84. Uh Z1 negative 0.84. See, and Z2 by symmetry they are equal. So that the Z2 will be positive 0.84. Okay. By symmetry. Symmetry. Okay. With these two, we can now get the lowest and highest possible score to qualify. Okay. So now let's see. Now, the lowest score, sorry, we not score my mistake. We can now figure out what the upper and lower readings, for the um blood pressure to qualify. So again, we're still using that same formula, which is that Z will now be equals sorry, my mistake. X equals Z times standard deviation, okay, plus the mean. So which means that for the first one, we have X1. For X1, we're going to use Z1, okay, and standard deviation plus mean, okay. See, so I'm gonna adjust this a little bit so that it looks like the real formula. Adjust this, okay. Z1, which would be equals, let me copy this. Okay. And our Z1 is negative 0.84 times standard deviation of 8 plus the mean of 120, which is that's the one I need to copy. Okay. Now let me write this down so we can calculate it. So I got X1 equals Z1, sorry, equals negative 0.84 times 8 plus 120. Okay. To have put this in the calculator, we have Negative 0.84 times 8 plus 120, which give us 113.28. 113.28. Okay. 113.28. Let's go and put it right there. Uh, 113.28 millimeter of mercury. That's how they measured, I think. Now, for X2, at the upper range, will be Z2 times standard deviation plus mean, which is, in this case, remove negative sign. That's all you need to do. And it will give you the answer right away. So I'm going to remove negative sign from the calculation. And they give me 126.72. 126.72 of millimeter of mercury. So that means, because the question was like, find the upper and lower readings that will qualify people to participate. The upper reading is 126.72 millimeter of mercury, and the lower reading is 113.28. Any question on this? Okay. Okay, no question. Good. Good. Now, you can try this one as a practice for yourself. Let's go to central limit theorem. Now, central limit theorem, in fact, excuse me, the sum and substance of what central limit theorem is talking about is that as your sample size increases infinitely, then the distribution of the sample mean will approach a normal distribution with a mean that is equal to the population mean, and the standard deviation that will be equal to the standard deviation divided by the square root of the sample size. So that standard deviation divided by the square root of sample size is what we call the standard error. Now, for central limit theorem, when we try to transform the variable, we use this formula here, that you can see here. Z equals to x bar minus mean divided by the standard deviation of n. To make it simple, it's better to use a simplified version of this formula, which is this one here. Okay. So all normally distributed variables, or let me put it this way: when solving a question that involve the central limit theorem, you do this. It is something so that in this second one, let me highlight this one as well. In the second one, you get the numerator first. That numerator is called the standard error. Once you get it, and you plug it in, and then you can answer your question. So let's do two examples here. How to get the standard error and also how to answer questions that involve central limit theorem. Excuse me. Okay. We have this question. It says the AC Nelson reported that. Make sure I've seen this. Okay, good. AC Nelson reported that children between age 2 to 5 watch on average 25 hours of TV per week. Assume that the variable is normally distributed with a standard deviation of 3 hours. If 20 children between the age of 2 and 5 are randomly selected, calculate the standard error of the mean. Well, how many of them were selected? N is 20, and the standard deviation is 3. So the standard error will simply be, look at the formula right here. I'm going to just copy it right here. Okay. I have it right here. I'm going to put it under this. Maybe I should just get it from it's right there. just the standard deviation divided by the square root of n of the sample size. See? I should highlight it. So in this case, we have our n as 20. And we have our standard deviation as 3. So that the standard, it says calculate the standard error of the mean. Okay? Standard error equals 3 divided by square root of 20. 20. Square root of 20. I don't have the symbol for square root right here with me. Let's see. Yeah, right here. Square root of 20. Okay? So we can get it from the calculator. Got 3 divided by square root of 20. 0.671. We round it to 2 decimal places. 0.671. Okay? 0.671. So that is how to get the standard error. Very easy. So now, at this point, we're ready to take a look at the application of the central limit theorem. Before I do that, does anybody have a question in what I just did? Any question in what I just did? Okay, no question. Good. Now let's look at the application using question number 13. Okay. It says there is a large supply of special energy saving light bulbs with the average life of 890 hours and the standard deviation of 50 hours. A random sample of 49 light bulb is drawn. A, calculate the standard error of the mean. B, find the probability that the sample mean will be less than 1,000 hours. Assume that the lights on the light bulbs are normally distributed. So first thing is to write out the summary statistics that are given. Sample set, how many of them are 49 light bulbs? So I'm going to write 49 here. And then the standard deviation is 50. And the average sample mean, the mean of the population is 890. Let's find the standard error. So the standard error okay, equals the standard deviation, okay, divided by the square root of which is the square root of the sample size, which should be standard deviation of 50 divided by the square root of the sample size, 49. That gives us 50 divided by 49, square root of 49. So I'm taking it to calculator. We got 50 divided by the square root of 49, which is 0.7143. 7.143. Standard error equals 7.143. Right? Okay. I mean, when it's rounded. Okay. When it is rounded. Now we can I wrote it down, I believe, somewhere here. Oh, got it. 7.143. So let's come put it right there. Our probability is 7.143. So we have your standard error. But this is find the probability that the sample mean will be less than 1,000 hours. So I'm going to draw this chart so you can see how it looks like. I got 0, I got Z. Um, uh, First of all, I have to transform this mean, sorry, the 1000 to a Z. Let me put all these numbers here first of all. I'm going to list them here before I start drawing this chart. So it says, after that, it said find the probability that the sample mean will be less than 1000 hours. So our X equals 1000 hours. So you have to transform this S to a Z before you can draw the chart. So the formula to use, like I said, is this one here, right here. So I'm going to just copy it. Okay. And paste it here. So you can use it. Sample mean minus population mean divided by standard error. Now we have the standard error calculated as here already as 7.143. We don't use that. So our Z become sample mean, which this is X bar. You show to X bar, sorry, X bar, not X. Sample mean, which is 1000, right here, 1000 minus population mean, which is 890, close the parenthesis and divided by standard error, which is 7.143. Okay, 7.143. That will give us our Z. So I'm going to write this down so we can get it. Z equals 1000 minus 890 divided by 7.143. Okay. So we're just going to put it on the calculator. Okay, 1000 minus 890 divided by 7.143. Okay. Give me 15.4 approximately. 15.4 approximately. Okay, because I got it right here, 15.4. 15.4. Now note that it's no longer X 1000. It's no longer X, it's now a Z. And it's no longer 1000, it is now 15.4, which means that the probability that the mean will be less than 1000 hours becomes the probability that Z is more than, I mean, it's greater than 15.4. Oh, you said less than, right? I think you said less than. Less than. Oh, less than. Oh, sorry, my mistake. To be less than, not greater than. Less than. Less than 15.4. So for this, excuse me, make a chart. So I will help you to figure that out. 0, 15.4, and then you make the chart. Then from here, go from here. Okay, I'm going to move this a little bit. Well, I think it's good. I think it's good. So now you put the center line. And then put the Z. It said it says here less than 1000 hours. So I'm gonna shed this. Everything on the left side is less than 1000 hours. So which is less than Z. Okay. Okay. See? Less than that. What it is. So now, to do that, to solve it, we use this formula right here. The Excel formula we used to get it right away. So let me write it down. Equals num dot s dot dist z comma true. And our z in this time, sorry, our z is 15.4, where z equals 15.4. And we're looking for the probability of z less than 15.4. So let's go and get this from Excel. We got we got okay, you can see it. We got to avoid confusion, move it this away. Z equals 15.4. 15.4. So that the probability of z greater than, sorry, less than, less than, okay, 15.4 equals to, excuse me, may order them to be the same size. Make it just make it 14, 16 should be 14 should be good enough. I'm gonna expand this. Okay. So now again, this is the formula. Let me show you the formula again before we now type it in. Formula is right here. Num.s.this z comma true, because I'm using cumulative probability, cumulative binary probability distribution. So that we have this as the from the Excel, we have equals num dot s dot dist. Okay. Click on z comma and type true. Close the parenthesis. Then press the enter key to give you answer right away. Approximately 1. Yeah. I mean, it's 100%. That's what it means. Probability is less than 1. 0 is from 0 to 1. So this one is a certain event. So you're gonna be like, if you want to make it more than 2, one decimal place, you can just be 1.0, that's what it means. So equals 1.0 from Excel, of course. Again, alternatively, you can use tables. Right? For this class, we're using Excel. Okay. Now, any question for this? Okay, no question. So you can try this one as a practice at home. Now I can now close this so we can start confidence interval. Okay. Confidence interval. So I'm going to open it. And then normal distribution. Confidence intervals now. Okay. And I close this one. So you can begin. I'm going to open a cell for confidence interval. Okay. Right. All right. You can share it. I'm going to close this one as well. The confidence intervals. Yeah. All right, see. Yep, confidence intervals now. Now, what is a confidence interval? Um, in statistics, we use the term confidence interval when we are trying to explain an estimated range of values that will contain the population parameter. Okay? For example, a confidence interval for the mean is a way of estimating the true population of the mean. Instead of using a single value, we use it to like when I take a population parameter sometimes, people will be looking at students will be looking at me as if I'm something that just fell from the moon. But actually, it means a numerical estimate of the population's population. Well, no, let me put this let me put it this way. A number that describe a population's characteristics. For example, population parameter for the mean, we have this symbol mu. So, and for the standard deviation, we use delta, and for the proportion, we use p. These are parameters, number that describe the population characteristics. So these are things we are trying to estimate when we do confidence intervals. So, confidence interval have two values: the lower end and the upper end. So let's start with the point estimate. This is the one that most of you are familiar with. One single number. So a single number that estimates the population parameter. Usually for mean, the best point estimate for the population mean is the sample mean. For example, a local bus driver might claim that the average price of gas, of course, in 2022 is $3.67 a gallon. Right now, as you know, gas prices are skyrocketing. Very scary sometimes. Anyway, Ford CEO can say that on average, 200,000 cars we are manufacturing in 2013. So you can see each of them single number, one number. So that's not what we are interested in here. In confidence interval, we're looking for two numbers. One is the lower number, then the upper number. For example, the same local bus driver can say that the average price of gasoline, remember the parameter here is average or the mean. So he's trying to estimate and say that the average gas price in 2022 is between $3.50 and $4.50 a gallon. So that can see two numbers that can accommodate other prices. Ford CEO can also say that the company produced on average 190,000 to 250,000 cars in 2013. Again, two numbers, lower and upper. So when doing confidence interval, we need to be conversant with some terms. For example, I've already explained to you what the that when we're doing probability, I explained a lot of terms for you. Now, this term we are going to be using here, one of them is the confidence level, which is the likelihood that the true population parameter, such as the mean or the standard deviation, lies within the range specified in the interval. The most common confidence level we use in statistics are 90% confidence level, 95% confidence level, and 99% confidence level. So if you're 90% confident, for example, that means your chance of being wrong is 10%. If you're 95% sure or confident, that means your chance of being wrong is 5%. Similarly, if you are 99% confidence, your chance of being wrong is 1%. This kind of 99% can be the pharmaceutical industry have to use this, and even people in the medical field have to use 99% because this is life. Patient life is at stake. Now, another thing we need to know is critical value. This is the number at the borderline that separates the sample statistics that are likely to occur and those are unlikely to occur. We use it to find the error margin because there's going to be some errors in it, whether you are doing the calculation or you're working on something. There's sometimes there always room for corrections, which means that there's some errors. So, excuse me. So, the critical values help us to find that error margin. Okay, and we call it critical Z alpha over two. Alpha over two because that now is two values. So you divide by two to get the lower and upper. Okay. So the first thing we need to know when we are doing confidence interval is to know how to find the critical values. Like I said, if you're 90% confident or sure, a chance of being wrong is 5%. If you are 95%, then a chance is 5%. And if you're 99%, the chances becomes 1%. So let us figure out how to find the critical value for confidence interval. Now, because confidence interval has to do with two sides. It has to do with two sides, the lower end and the upper end. Um, we we're looking for critical value for only for uh, you know, the two sides, the upper and lower. Actually, I'm putting it this way. For two tails. I call it two tails. Because it's on the left side and the right side. So now, anyway, now let's look at this first question. Say find the critical alpha. Excuse me. Yep. Say find the critical alpha and the critical values using the information here on the table. So these are the information. Confidence level, which is 90% to 98. Alpha. So listen to there's two ways you can do this. Either you use table. In this case, we use this formula to divide and then look for it on the table. But to save time, we're gonna using Excel for this class. And this can be asked this question can be asked in different form. It can be asked to be like in form of a table here, and they want us to get the critical value for all the confidence level. Or they can be asked in this way: find the critical value Z alpha over 2 corresponding to 92%. See? So for that, because of that, I'm gonna add 92% here. 92%. Okay. So now let us go and put it in Excel so you can find the critical value. I put it in Excel. So you have critical values. Let's see. Maybe I should open a new one. Let me add a new one right here. Critical values. So you have confidence level. Okay. Excuse me. Then alpha. Alpha. Which you can find, from here. Alpha right here. Mhm. Then critical value. Which is Z alpha over 2. Okay, about 2. So as a critical value. So I'm going to adjust this, make them to be the same font size. Okay, 16 should be good. As a matter of fact, 14 is good enough. Confidence level, critical value. Okay, and from the equation they gave us, they have many. They say 90%, 95%, 99%. 90%, 95%, 99%. Next would be 98% and 90%. 98%, 92%. So the formula for finding the critical values using Excel, I'm gonna write it big on this side. Okay. Equals is, what is it? As a matter of fact, I wrote it on paper there for you and the handouts for you as well. I think I have it here. Yeah, you can see it all the way to the end. I have it right here. Finding critical value for confidence level. It's in Excel. I can see right here. But I'm going to write it for you anyway. Okay. Okay. We have, oh, excuse me. Put it right there. It's gonna be equals number S dot inverse. Okay. 1 minus half over 2. Just half over 2 be good because we're going to do 1 minus alpha here anyway. Alpha, okay, 1 minus alpha, 1 minus alpha, 1 minus alpha over 2. Why equal sign? Because remember I explained the last in the at the end of the semester when you want to do a calculation that involve Excel, you have to use the equal sign first to make sure that it's in the ready mode. So let's do this. Now, 90%. If you're 90% confident, your chance of being incorrect is 10%. So your alpha is 10%, which in decimal form is 0.1. If you're 95% confidence, your chance of being wrong becomes 5%, which is 0.05 in decimal form. For 99%, 1%, which is 0.01. For 98%, the chance of being wrong is 2%, which is 0.02. Then for 2% is 8%, which is 0.08. Okay? With this, you can now get a critical value using this formula on the right side. Num.s.inverse 1 minus alpha over 2. So let's get the good things about using Excel that when you get the first one, you can just copy the formula down to get the rest of them. So it equals num dot s dot inverse. Okay, 1 minus alpha, but alpha is for the first one is 0.1, which you click on it, divided by 2, and close the parenthesis. So that when you press the enter key to give you the critical value here, 1.64, and then you can copy the formula down, it will calculate the rest of them. Then you can make it 2 decimal. We normally use 2 decimal places, 2 decimal. So that's our confidence in that critical value right there. Okay. It's critical value right there. Okay. Now I can just make it, more clear. Then this is a critical values, right? I'm just going to highlight it. I can just copy this and paste it in Word while we are doing our work here. But for you, if you're doing this as an assignment, you just submit the Excel file. See? So any question on this? Any query? Any question? Okay, no question. So that's how to get it. Now that I've shown you, if you have a question, please ask me. I don't do chat. I don't go to chat room when I'm, teaching a class. Now, you can try the rest of this on this side as a practice. Let's now look at how to find the confidence interval for the mean. Okay, the confidence interval for the mean. When sample size is large. In statistics, we say that sample size is large when the sample size is greater than or equal to 30, so long as they are selected at random. First thing is to find first step is to find the critical value. Second step is to find the error margin using this formula here. Okay. Then find the constant interval using this formula below it, which one right here. Then you can now make a conclusion. Okay. Now, this is if you are using the formula method. For us, we'll be using the Excel method. So let's do this example here. I'm going to move it down so we have enough room for this. Okay. Yeah, move this other one down. Okay, it says a sample reading scores of 35 fifth graders has a mean of 82 and a standard deviation of 80, sorry, have of 15. A sample reading scores of 35 fifth graders has a mean of 82 and a standard deviation of 15. We say if I say find the 95% confidence interval of the mean reading scores of all fifth graders. B say find the 99% confidence interval of the reading scores of all fifth graders. So the first thing is to get our small statistics. We are told that the mean n is small n, not small n. Sample size is 35. Got that the sample mean x bar. Okay, x bar equals 82. And the standard deviation, okay, of the population is 15. Delta, I'm gonna make this is be bold. Standard deviation is x bar is delta equals 15. Delta equals 15. So now you have to find the confidence. Well, this is for 95% confidence level. Confidence level. Well, I'll call it alpha. Alpha. Since the confidence level is for part A, it said 95% confidence interval. So the alpha, if confidence level, I'm gonna put it on the other side. I'm gonna say okay. I say confidence level equals 95%, which means that your alpha, okay, alpha will be, that means your chance of being wrong is 5%, which is 0.05. Now let me write this thing down. You can put it in Excel so that you can get our confidence interval. Let me write them down. Okay, n is 35, x bar is 82, delta, standard deviation is 15, then alpha is 0.05. Let's go and put them in. We come to Excel right here. So I'm going to take it in interval. take it to this place. Make this a little bit, 15. Okay. So now, sample mean is 82. Make it 16. I do the other one. Good. Standard deviation. No, population standard deviation, not sample. That's population standard deviation. Okay. Is 15. Sample size is 35 fifth graders. The confidence level is 95%. Which means that your alpha, I'm gonna put that here. Alpha will be okay. Alpha will be 5%, which is 0.5. So now with this we can get our error margin, which is the E. Error margin, which is the E. Oops, excuse me. it always do that. I don't know why. E. Let me move it like that. Okay. The formula we're going to use to get E, I'm going to write it. Let me see if I can write it here. Move this one a little bit up. Okay. Oh, excuse me. I'm going to bring it down a little bit. Okay, good. That's excellent. Now, let me put the formula right here so you can see it. I have it on the handout too, so you can see both of them. I'm not going to be like this. Okay. Equal confidence dot norm dot norm. Okay. Alpha, comma, okay, standard deviation, comma, and then sample size. Okay, so I'm going to make it a little bit bigger so you can see it properly. Make it like 14 and bold. Okay, maybe yeah, 14 is good. Make it bold. Probably, why is it going back to 15? Okay, right here. That's it right there. So now let's put it right here. Confidence. Oh, confidence. Dot norm. See? Click on alpha, which is right here, 0.05. Come on. Then, excuse me. Say, I can even see it right here. Standard deviation, which is 15, comma, and sample size, which is 35. Then close it. Press the enter key. Give 4.969 or 4.97 if you like. Since I'm using two decimal places, I can just make it 4.97. Okay. Now, once you get this error, you have the confidence interval, the lower interval, you subtract this, and for the upper interval, you add this. So lower interval becomes equals 82 minus the error. But give you this, you can see right here, S bar minus error. This is the mean you're trying to estimate right here. This place is going to be X bar plus error. So in that case, equals X bar, which is 82, plus error. Give you 86 point, where's my, listen, 86 point, excuse me, 86.97. Now we can now look at the this is a confidence intervals right here. Lower interval, upper interval. I can just highlight it, make it clear, then copy it and paste it so we can conclude that side of the work here, right there. See? Now let's write a conclusion. Conclusion. Because they want us to find the 95% confidence interval for the true mean, true reading scores. So that means, well, we can say with 95% confidence that um that proceed find 95% confidence interval of the mean scores. So that means the average reading scores of fifth graders. That's the average reading scores that the mean, you have to mention the mean. If you don't mention the mean, your answer will not be, your conclusion will not be incorrect. So that you get points for the calculation, but not for the conclusion. So make sure you mention, because you are trying to estimate the mean. You must mention the name of the parameter you are trying to estimate in your conclusion. So that the mean reading score of all fifth graders is between 7.03 to 86.97. Okay, that's answer part A. Now part B says find the 99% confidence interval. So you're doing the same thing, but this time around you're using 99%. Now again, that is where Excel have an advantage. So as a matter of fact, yes, that's why you have an advantage. So taking Excel, all you need to do is to go to Excel and just copy this here on this side and paste it beside it. Okay. Then, see, this time I talk about 99%, so that you're going to be using 99% to going to be 0.01 for your alpha. So let's change it to 0.01, it will calculate it. That's it. See, you have it right there. So I'm going to copy this whole of this and use it to replace the one we have already. Okay. So I'm going to erase this one and put a new one. So you can even, so when they put them side by side, you can even compare them. So part of it, in that case, we can say with 99% confident that the average mean reading scores is between 75.47 to 88.53. See? And that's it. Answer that. So, but of course, for you, you're going to submit an Excel file for if it is you doing it, so I can verify your answers. Okay. Any question on this? Okay. So no question then. Now, sometimes the question might be asked in a different form, like this one here. It said a random sample of number of farms in thousands in various states were as follows. So number of farms in various states. They listed it there by part one states. It's number of farms in each state. But these are in thousands. Like for example, first this state has 47,000 farms, and this one have 95,000 farms, and so on. It said estimate the mean number of farms per state with 90% confidence. Now, unlike this other one we just did, where they give us the summary statistics, they give us the mean, they give us the standard deviation. In this case, you are going to calculate it by yourself. Okay? Of course, the first thing to do is to put the data set in Excel. And once you calculate it, then you follow the same process. On the left, once you get your error margin, on the left side, you subtract the error margin. And on the right side, you add the error margin. So let's go and do it. First of all, put this in Excel. You have it in Excel right here. So you can see it right there. Oh, excuse me, sorry. Scroll down, you can see right here, have the numbers in all the way to the last one. So to make it fast in Excel, for this type that you are giving the raw data, what you're going to do is to click on data analysis. You can see what you have. Let me make sure I'm seeing this. Okay. Descriptive statistics. Click on that and click OK. Okay. I think you went somewhere else. Make sure you're seeing this. Okay. Now, with this, can you see the? Let me cancel this. Yeah, let me cancel it. Now let me start all over on that section. Okay, go here. Now, when I read this part. Okay. Now, for this, just go to data analysis, choose the statistics, and click OK. Now, for this one, click on this and then put all the data sets, all of them. Okay. Click here. Then it's on the column, so you can read if it's arranged horizontally in rows, you can choose rows, but this one is in columns. So now you don't have any title for it, so just leave the data blank. And for output range, I'm going to choose here by the side here. I'm going to put it right here. Then you need the summary statistics. They need confidence level. This time around, they say use 90%. So that we put a 90 here. They can please OK. See, it gave you all the information all the descriptive statistics. Give you the mean and the standard error. This is your error margin right here. Okay. So you can make it make everything like this. This is what you need, the standard deviation. You need this standard deviation is you need this one. So make it to the smart places. Oh, sorry, my mistake there. Then you need this one, make it to the smart places. Okay. So what else we need? Standard error, with confidence critical value, make it to the smart place. So you have everything now. You have your mean, you have your standard deviation. But the most important thing that you have your mean and the standard the critical value. So to find the confidence interval, you type in here critical value or critical value. Oh, the error margin, I mean to say error margin, error margin. Okay, you have it here as 9.53. The mean, sample mean, excuse me, sample mean, which is mean you're using to estimate the population mean, is 43.45. And then standard deviation. Okay, you don't need it anymore because you already have your confidence critical value. So that we have lower interval, okay, that upper interval, okay, lower interval and upper interval. So now, as you know already, the formula for both the lower and upper interval, you can see it right here. On the left side, you subtract the error, and the right side, you add the error. Okay, so that we have in this case, we have everything we need equals mean minus error. Press enter key, giving the lower interval. For the upper interval equals mean plus error. So that we have, you can then yes, you can then just have this. This will have 43.4 sorry, 43.92 lower interval. Okay. 33.92, and the upper interval will be 52.98. 52.98. So our conclusion now becomes that we can say we are 90% confidence that the average number of farms in each state is between 33.92 thousand farms to 52.98 thousand farms, based on a sample of 31 farms, 31 states. Okay. Any question for me on this? Yeah. You can try as many of them that you want. Let us look at how to find the minimum sample size. Since there's no question, I'm going to proceed to finding the minimum sample size. Okay. Okay. The formula we use for finding the minimum sample size is n equals z alpha over 2, which represents the critical value, times standard deviation of the error squared. Okay. For example, I'm going to try one example here. This one is very direct. Okay. Excuse me. So it is desired to estimate the mean number of chocolate chips per cookie for a large national brand. How many cookies will have to be sampled to estimate the true mean number of chips per cookie with within two chips with 98% confidence. Assume that the standard deviation is 10.1 chips. So the standard deviation is 10.1 chips. Okay, so this is what it is. Can make it much bigger than that. Look, it's good. Make it, yeah, it's good. Then, you say that the confidence level equals, excuse me, equals 98%. Okay. So that your chance of being wrong is 2%. It's a within two, that's why it's a within two chips. So your alpha is 2%. So you can get a critical value z alpha over 2, alpha over 2 equals let me make this. it here equals, we can get it from the calculator. All right, we have can get it from Excel. I need to say, yeah, I can get it from Excel. Let me go down a little bit. Alpha, which is alpha right here. I'll put this symbol. We have it before. You just want to refresh your memory so you can remember how to calculate it. Like, okay, is because it's 98%, so your chance of being wrong is 2%, which is 0.02. So that the critical value z alpha over 2, critical value z alpha over 2, z alpha, okay, over 2 equals, oh, my mistake, my mistake. So critical value z, that's what it is. Critical value z equals, so equals num.s dot inverse, opening parenthesis. Click on probability is this right here. Actually 1 minus alpha over 2, 1 minus alpha over 2. 2.33. So I'll make it 2. Make it 2 decimal places. 2.33. 2.33. So I'm gonna take it to that place. 2.33. Then we'll say that, okay, we are given the confidence level to 2 chips. Then the error, we'll say that the error is 2 equals 2. We've done this, we can just plug it into this formula here and get our answer. Let me write them down. I can go and get the formula here. Excuse me. The z equals z alpha over 2 times standard deviation over error all squared, which is write this down. That standard deviation is 10.1. Z alpha over 2 equals 2.33. Error equals 2. Let's go and put this in the calculator. This place will not allow me to put in this formula. So I'm going to open a new workbook in Word. So we can get our this. So you have so that sample size, minimum sample size, and we're doing this. And equals, I'm gonna make it big. Equals, okay. Now put this right first of all. Now put all this thing that I needed. Then parentheses. Good. So you have remember the formula again. Let me show you the formula again so you can refresh your memory. Z alpha over 2 times standard deviation over error squared. And now Z alpha over 2 is 2.33. And then our error is 2 and standard deviation is 10.1. Let's go and put them in. So 2.33 times standard deviation of 10.1 excuse me, divided by error of 2 all raised to the power 2 equal. Let me put them here, okay, which is 2.33 times 10.1 over 2 squared. So let's go and put this in calculator. Okay. 2.33. That's good. Times 10.1 over error, which is 2 squared, 138.45. 138, let me write it down. 138.45. So I'm going to put it right there. 138.45. Now copy this and go and paste it in the right place. Right here. So that means we need 139 cookies. Why 139? Because whenever you have a decimal here, just go to the next whole number. Not the regular rounding that you have in algebra. This is just, so long as you have a decimal number, whether it is up to 5 or not, just go to the next whole number. So we need to make chips. We need 139 chips. So any question on this before we go to confidence interval for the mean when the sample size is small? Any question for this? Okay, no question. Okay, good. So now these other ones you can try as a practice at home. Let's look at situation whereby the confidence interval is for mean when sample size is small. In this case, when the sample size is less than 30. So for that, we use a table that is called student t-distribution table. But for this class, we'll be using Excel. But this table is based on sample size and the evaluator to call the degree of freedom. The distribution, the t-distribution was developed in 1908 by an Irish brilliant project that his name is W.S. Gazette. So anyway, so for this one, the degree of freedom, to find the degree of freedom, we use this simple formula n-1, where n is the sample size. Okay. So let us start this section by explaining to you how to get the critical value for t distribution. It's a little bit different from the z table. Let me put it that way. So because of you have to factor in the sample size. For example, this question says find the t alpha over 2 for the following confidence levels. 95% confidence level with n 22, 99% confidence level with n 10, and so on and so forth. So I'm going to put it on the Excel. So critical value for this one, okay? For this, we have 99%. And the rest of the, so I'm gonna just copy from here. Okay, and place them in Excel for you. And we can get the critical value. Okay. So you have the sample size and so this is alpha. Confidence level then alpha. For alpha, you have the excuse me. You have the if you're 95% confidence, your alpha is your chance of being wrong is 5%, so your alpha will be 0.05. If you're 99% confidence, your chance of being wrong is 1%, which is 0.01. So in the same way, we'll get the rest of them 0.10 and 0. For this one, I think it's 0.14. Let me see. 100%, 100 minus 86. So that if you 86% confidence. Your chance of being wrong is 14%, which is 0.14. No, excuse me. I clicked at the wrong place. 0.14. Now, for the sample sizes, I'll have it here. For the sample size, we have, for 95%, we have 22. So 22 times 14, 14. Okay. 22 times 14, 14. Okay. Now, degree of freedom is n minus 1. Remember, I just mentioned it a few minutes ago. To find the degree of freedom, just use n minus 1. I mean, sample size minus 1. So the sample size minus 1 is going to be 22 minus 1 is 21 now. I can just say equals this minus 1. Okay. And then follow the same process right here. Now, for critical value, now let me write the formula here so you can see the formula. I have it on the handouts too. The formula you use for that is, okay, because it's two side, lower side and upper side. So T, oh, excuse me, equals T, because it is a T distribution, dot inverse, because it's two sides, or 2T, in parentheses, alpha, comma, then degree of freedom. And once you press the enter key, it will give you, excuse me, it will give you the confidence interval. Okay? Let's do it for this one. And then you can get all of them. So you got equals T, oh, excuse me, T dot inverse dot 2T. Oh, hold on. Let me extend that section. It's too short. I mean, that space I mean to say. Okay, that's better now. Equals T dot inverse dot 2T. Okay? Probability, when you say probability, actually is talking about the alpha, which is the chance of you being wrong. Probability of you being wrong, which is for 95% is 0.05. Click on it, comma. Degree of freedom is 21. Then close the parenthesis. Once you press the enter key to give it the critical value, and you can just copy it down, copy the formula down to calculate the rest of them. I don't know why it stopped here. Okay, I'm going to just copy it down. Now I can just adjust this to the small places or even 3. And then you can just copy this and paste it down. Okay, go to your workbook. So you can put it right here. I gave you the formulas right here. So now, any question on this before we can solve some example on confidence interval when the sample size is small? Any question on this? Okay. So no question. Okay, good. Excellent. 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 Okay. We can then look at this question here. It says, now, before I answer that, I want to tell you something. When to use Z and use T. Now, here are the scenarios where you can use Z or T. Z is used when the sample size is large and we know the value of the population standard deviation. Use the Z table or use the Z formula in Excel. But for T, when the sample size is small and we don't know the value of the population standard deviation, we use T. In some cases, if the sample size is small, but you know the value of the population standard deviation, then you can still use Z. Okay? Now look at this question here. It says a sample of six um a sample of six college wrestlers. You can see the sample size is small. Six, only six. Has an average weight of 206 pounds with a standard deviation of 12 pounds. Okay. Um, Find the 90% confidence interval for the true mean weight of the wrestlers. If the coach claimed that the average weight of these wrestlers on the team is 310 pounds, would that claim be believable? So you're told that the sample size is 6 and the sample mean is 276. And the sample standard deviation S, let me make this thing to be I think S equals the 12 pounds and the confidence level is 90% confidence level. So that your alpha will be your chance of being wrong is 10%. Alpha will be 10%, which is 0.10. So we just put all this in Excel. Let me get on my paper. N is 6. S is 12. X bar is 276. And alpha is 0.10. So let's go and put just almost the same formula with the other one, but said that we use T this time, and then we're using sample standard deviation. So I'll take you there. Okay. So we have confidence interval for T. So I'm just going to copy this side and paste it on the paste it below of that. Paste it right here. Okay. So in this case, our sample mean we are given to be sample mean is 276. I'm going to make this side to be 18 like the other one. Sample standard deviation is, I'm going to also make this one to be, yep, is 12. Sample size is six wrestlers. And confidence, alpha is 0.10. And error margin, now for this error margin, we're going to use something similar. I'm going to show you the same formula we'll be using. I'm going to write it on the side. Okay. Equals, you're going to be not confidence dot T this time around. Confidence. Okay. Dot T. Okay. And alpha, comma, sample size. Okay. So I'm going to holding this. Okay. So I'm going to put it right here. Equal, you know what? I'm going to expand this one. No, excuse me. Let me extend this so we can have enough room for this formula. Okay, good. Okay. Okay, excellent. We have equal confidence dot T. Yep, dot T. Okay. Alpha. Alpha is 0.1. Click on the comma. Then sample size is 6. Then close the parentheses. When you press the enter key, to give you the error. I missed something. Okay. I forgot the standard deviation. That's what happened. So I'm gonna put standard deviation right here. I'm gonna put some. Okay, let me see. Okay, I put standard deviation right here. Standard deviation S, standard deviation, comma. Okay, now let's do it. Equals confidence dot T, opening parenthesis, alpha, comma, standard deviation, which is 12, comma, the sample size is 6, and close the parenthesis. And once you press the enter key to give you the error margin. So I can just reduce it to the smart versus 9.87. Now, to get the confidence interval, now, lower interval, just subtract this from the mean. And then to get the upper, add it to the mean. So lower interval equals mean minus error. Press the enter key, give me 266. And for the upper interval equals mean plus error. Give me 285. And with that, I can just highlight both of them. This is the confidence interval right here. I'm gonna use green to do that. So I can just copy all of this. I'll paste it in our main workbook and conclude. Okay. Okay. So this is what we have. Remember, it says, APA says find 90% confidence interval. We have it right here. Lower interval, upper interval. So we can say with 90% confidence that the average weight, okay, of the wrestler is between. Remember to put the average. You must put the average so that the answer will be correct. Because that's what you are trying to estimate, the mean. The average weight of the wrestlers is between 266.13 pounds to 285.87 pounds. Any question, guys? Any question? Okay, no question. So part B says, if the coach claimed that the average weight of the wrestlers on the team is 310 pounds, would that claim be believable? Of course, it's not, because it does not fall within the interval. It is 310 pounds. So but the answer is no, because 300 pounds did not fall within the interval. Any question, guys? Okay,
No questions.
Okay, good. Well, I'll see you guys next week. Please review this. This one you can just find the mean using Excel and the standard deviation, and then follow the same method, and you get your answer. Okay. Now, the test and the homework, don't start I mean, you can start them if you want, but I will make it to be due next Sunday, not this Sunday, next Sunday, because I want us to cover this part in next class for the proportion part of it. That's why I say you can wait and then start after our class next week. Okay. Any question before we leave?
No.
Okay, see you guys next week then. Any of you, remember what I say, if you have your attendance up to 70%, send me email with the name of the 4 assignments you want to make up, okay? Hello? Can you hear me, guys?
All right.
Yes.
Okay, good. So I see you guys next
I
week.
wanted to talk to you about something.
Who is speaking?
Nevaeh.
Miss Neve, yes, I got an email from your mom and from the school, and I responded.
Yes.
So, yes, remember your situation, you just your attendance Not good.
And and I understand that.
Hold on, Miss Navarro. So, but your case is a little bit different because you have um your PSN account was is messed up. Remember,
Yes. I
I
wanted to
never
let you
know
know that they fixed it. They
the,
fixed it, but I need a code.
the code is right there. Remember, I said it at the beginning. It's right here. You go
Yeah,
here.
but they said that I need a new code.
What do they mean by that? It can't be a new code. See, it's
Let me
right
see.
here.
In the email that they sent me, they said
Can you
that
see
would have to
can you
be.
see the screen?
Yeah, I can see your screen. Yeah.
Yeah, it's right here. You click on the course material.
Okay, I'm clicking on my computer right now.
Mm-hmm. Well,
Okay, reveal access code.
yes. So it won't be different. I think maybe it will be different from your screen, but you're gonna say reveal access code. That's where the code is. You click on it, you get the code, you copy the code, right?
I'm doing that right now. It's
Once
loading.
once you copy the code, now you go back to the
But
class.
it always says that it's not gonna let me in.
Yeah, have you tried this one now?
Yeah, I have tried that one. I
Or
tried that once they told me that my thing was open. I tried it again and it didn't work for me.
try it right now. If it doesn't work, then I have to do what I did. Like, remember, I didn't know it was you that I have my class last semester.
Yeah, it was me. Yeah,
Yeah, but the problem is that remember, if you remember, I gave you a work packet and you
I
completed it,
do.
and I put the grades there. But when you got the D's because you didn't submit the project, and there are also some classwork you didn't do.
hmm
That's what I explained
No,
that to your mom.
I understand. I understand that part. It's just that I need the code so I can be able to do the
Yeah,
other
the
assignments.
the,
But
the only, the only
so
code.
I'm trying the code right now, but my Wi-Fi is a little tripped up. But if the code doesn't allow me to work, if it doesn't allow me to go into tomorrow, is there a way that we can meet in person so we can do it like together?
Tomorrow I'm not available tomorrow, but
No, it don't have to be tomorrow. It could be sometime this week.
even if it's me, Miss yeah, because I don't have control over the code. That's why
Okay,
when you said that
I understand that.
when they said they fix it, I thought that means you can get in now. I don't have the only one I can have is the one you just see. So me being there is still gonna be the same thing. I don't have control of is Pearson and you that can fix that. So what I'm suggest, like I said last semester, the only reason you get that D because you didn't submit. If you want, I can show you. I graded
Mhm.
everything and put them in
Mhm.
so that Pearson part was fixed.
Okay.
Yeah. So if you checked your grade last semester, what makes you to have that D? Because I can show you if you want.
What's the code again? No, I understand what made me get the D. I understand that part.
So now I can give you
I
something else. What I can do on my side, I can give you an work packet
okay.
and give you makeup. But
Okay.
this time, make sure you submit everything.
Everything. I understand that. Thank you, sir.
Makeup separate. So you can request 4 makeups. Then
Okay.
the work packet I'm gonna give you, you must have to finish it by the deadline. Remember, send it to me.
Okay.
Then I'll
Do
grade
it send
it.
it to you via email?
Yes, well, both of them emails, two separate email.
Okay.
One for the makeup. You can. I'm sorry. Unfortunately, I can't give you more than 4 makeups. You have
Okay,
to.
I understand that. I
Right.
understand that.
Then then I'm gonna give you two separate email.
Mm-hmm.
The work packet for the Pearson.
Hmm.
So I think I explained that to your mom and yeah this.
Yes.
So
I understand that part. Thank you.
you're welcome. So send me the email. Tomorrow I will start responding to the makeup requests.
Okay, I'm gonna send you an email right now.
And so send it tomorrow evening because tomorrow all day I'm busy all day. I won't be able to respond in that.
Okay, I understand.
All right, see you guys next week.
Okay, see you next week. Thank you.
Bye bye.
Bye.
Professor, I have a question.
Yes, ma'am.
I've been emailing you regarding office hours. Could you just please get back to my emails?
Oh, the office hour. I'm not free this week. Honestly, I'm not free this week. But what do you need anyway?
My piercing was down. I got it working back now. I just want to know if you could open up the assignments.
But this is the time you may send the email. Remember that this is the time your attendance is up to 70 now, right?
Yes, my attendance is good.
So you can request to make up 5 assignments. You can include those ones in your email. Have you sent the email about? Have you made the request yet?
I'll send a new one. But
Yeah.
I sent previous emails, yes.
So set it 4 assignments you can make up. Okay.
Okay, thank you.
Tomorrow I will start Tomorrow evening I will start responding to those requests.
Okay, thank you.
You're welcome. All right, guys. Have a nice evening.